is located in the central office of the telecommunications carrier. Mm, and the DC equipment is also owned by the telecommunication provider itself. So all the responsibility is on top of the telecommunication provider only. And the majority of the today's friendly networks are public carrier provider networks. The other category is the private enterprise networks. So here the responsibility is divided into two things. So the first one is the administration and the maintenance activities in the network are being carried out by the enterprise themselves, and the equipments including the switching equipments is all owned by the customer, so the responsibility is shared. Now moving on to the frame relay frame formats, we have two formats. One is the standard format and another one is the LMI frame format. First, coming to the standard frame format, so it contains the data link layer frame format, basic formats, flag, address, data, FCS, and finally the 8-bit flag. First, about the flag. Yes, the flag bit, it represents the beginning and the end of the frame. It is the delimiter value. And then the three important components are the header and the address area, the data portion, and the frame check sequence. What about the address area? So it is of 2-byte value, 16 bits totally. The first 10 bits represent the circuit identifier and the 6 bits related to the congestion management. So in case of the BEC and FECN, this can be utilized. So that is about the flag area. And then what about the flag value? So it is the delimiter value. It has a constant value which is a 0 followed by 6 ones and 0. So this is the default flag value. And then about the address. In the address field, so there is indication for three portions. One is the DLCI extended address and the congestion control value. So as we have already seen, the address will contain 16 bits. So it can be divided into 10 plus 6 or in this way also. First about the DLCA, which is data link connection identifier. So it is a 10-bit value, and this contains the details about the connections, that particular link's identification number. So it has the local significance, and devices at the opposite ends can use different DLCA. So from the sender end, for that particular link, they can have identification number. Similarly, from the receiver side, they need not have the same thing. They can have a different DLCA value for the same virtual connection. So next one is extended address. This is to indicate whether the byte in which EA value is the last field or not. So it can have some extended bits available. And then congestion controller. So it has 3 bits value. It tells about whether it is an FECN, BECN, or the DE. What is the DE bits? We have seen in the previous slides. It is yes, it's the discard eligibility bit. So this discard eligibility, the name itself tells it has got a lower priority, and in case of congestion, this will be discarded. This has the eligibility to get discarded first. So that is it. And yes, FECN, BECN, and the DE bits. Then coming to the data, so it contains the encapsulated upper layer data. It serves to transport the higher layer PDU through the frame relay network. And then the frame check sequence. This is to check the integrity of the transmitted data, whether any error has occurred or not. And that is all about the standard frame format. Then moving on to the LMI frame format. This has some additional frame format. So it has got some 9 fields in it. Yes, it starts with a flag. It's the same delimiter value at the beginning and the end of the frame. Then coming to LMI DLCA. So it is the connection identifier. It identifies the frame as particularly the unique LMI frame instead of the basic frame relay. And then comes the unnumbered information indicator. This is to set the polar final bit. So what is the pole and the final bit? So the pole and the final is for it's like a